students. Today we are continuing the solution chapter. So in the last class we have discussed about what is solution and the types of solution. And in the previous classes, the types of solution, among that which is the solid, solute, and which is the solvent, the different kind of the solvent. So based on that we have observed the 9 different types of solutions. So major it is 3, but example purpose it is 9. So you have to give the preference for that one. And molarity, molality, and all the mole fraction, it is a basic concept. Moreover, they will not ask you, but molarity, molality, only these 2 are important. So keep in your mind. And so today, based on your notes of your sending, based on that one, I will decide to whom I have to send the notes. So it's my request. I don't bother about when I have to send the notes, because if your responding is very good, so that I can send you all the notes at the time initially. So else you have to wait for up to the end. So don't do like that. So try to send the notes as soon as update, so that you will get there is no worry to write the notes. Okay, coming to the solution chapter. So today we are discussing still some important points. These are the theoretical points. You can able to understand, you can able to answer to these questions only on the basis of if you are thorough about the concepts. If you understand the concept, you will feel very easy. Only thing is we have to apply that. So let's begin. So in the solution, the next one is heading dissolution. What is dissolution? But they will not ask you the definition, dissolution, but you should know the meaning of dissolution. What is dissolution? So dissolution is nothing but think that the salt I am adding that salt into the water, means salt is dissolving in the water. So water it is a solvent, salt it is a solute. So solute is going to mix in the water. The process of mixing is called as dissolution. Dissolve, whatever we call it, the dissolve. That dissolve itself is called as dissolution or dissolution. Everything is same. So dissolution is nothing but it is a process of mixing the solute in the liquid. So it is not the definition. Definition is means if they ask what is a dissolution, define dissolution means dissolution is nothing but it is a process where solute particles leaving its phase, solute particles leaving its phase and mixing with the phase of solvent. Means initially the salt it is being the solid. When we mix with the water, the salt which is being in a solid, it's going to form as a solvent phase, means it's going to form as a liquid. So it means that solute being a solid, it's going to convert as a solvent, means when it mixes with the solvent, it's going to leave the solid state and forming as a liquid phase. So it means that dissolution is nothing but it is a process of leaving the solute phase and converting into the solvent phase. This process is called as dissolution. Are you getting my point? So this is the definition. They will ask you for 1 mark, so you should be capable to write the dissolution. You should remember the meaning. Meaning is very simple. Mixing of solute in a solvent, but you are not supposed to write the meaning, but to write the particular definitions. So coming to the example, what is dissolution means? These are not the actually different types of dissolution. You should remember the meaning of this one, because polar compounds we can take a solute and solvent. So here majorly polar compounds are soluble in polar solvent. So polar compounds are soluble in polar solvent. What it means? Polar is nothing but you should remember. So polar is nothing but there are 2 actually, polar and non-polar. So sometimes whenever we are using the word polar, so polar is nothing but they should exhibit the dipole. So dipole is nothing but whenever we say NaCl, of general I would like to take here CH, C2H5OH with ethanol. So ethanol, so here ethanol, eth is being a positive charge, OH is being a negative. The rich electrons at OH and poor electrons means deficiency occurs at carbon and the rich electrons occurs at hydroxide. So it means that if the compound carry positive and negative poles, one end is positive and another is negative, such kind of poles occurs means then it's called as a dipole. The compound, the substance, the molecule which exhibit the dipole, those all are example for polar compound. Therefore, here the polar compounds are soluble in polar solvent. The polar compounds, the polar solute, the polar solute are soluble in polar solvent. Polar solvent. The best example for polar compound is one is ethanol. So you can take another compound. Polar compound. I would like to write the water as a polar because water can able to dissolve the alcohol compounds also, and moreover, so we can write the salts also because sodium chloride, magnesium chloride, these are going to carry the polar. They are exhibiting the dipole because sodium carry plus, chlorine carry negative. No doubt it is also polar compound, but moreover we are not writing this salt as a polar because for particularly salt compound we are writing that the salt means NaCl, magnesium chloride, any of the salt. These salt I am considering as a ionic compound. So these are the ionic compounds. So tell me whether ionic compounds are soluble in polar or not. Ionic compound means magnesium chloride, aluminum chloride, every salt whichever we are using. So these ionic compounds they are soluble in water. Therefore, it means ionic compounds are soluble in polar solvent because ionic compounds are also exhibiting the dipole. Therefore, these are soluble in polar, and polar compounds being a dipole, they are also soluble in polar. So keep in your mind, polar compounds are soluble in polar solvent. Even ionic compounds are also soluble in polar solvent. Similarly, the non-polar compounds are whether it is soluble in water. You have to think why, because non-polar compounds are nothing but non-polar solute. You can take non-polar solute also. The non-polar solute, the example is CCl4, means carbon containing 4 chlorine, or carbon containing majorly these are not exhibiting the dipole. If they are exhibiting the dipole, they are polar compound. If they are not exhibiting the dipole, then we are considering that as non-polar. Similarly, CH4, methane. So here methane and CCl4, not only this compound, carbon dioxide we can take because C double bond to double bond. The opposite they are having negative and it will be cancels each other. So similarly, these are the compounds which do not contain the dipole. Such kind of compounds are called as non-polar compound. The non-polar solute are soluble in non-polar compound only. Non-polar solvent, because water it is a polar compound, means it is not soluble in. Non-polar compounds are not soluble in polar compound, means polar compound, the best example is water. So it means the non-polar compounds means carbon tetrachloride, methane, these are insoluble in water, but these are soluble in non-polar solvent. The example for non-polar solvent is benzene, toluene. We can take any of the compound which is containing the benzene or benzene derivatives. So these all are example for non-polar solvent. The main thing you have to remember is polar compounds are soluble in polar solvent, non-polar compounds are soluble in non-polar solvent. The main thing you have to remember, and the secondary is ionic compounds are soluble in polar, means it is soluble in water. I hope this is clear for you. In the dissolution, the continuation of this dissolution. So what we have to thinking is the one more most important definition is solubility. So when solid compounds are mixed in a solvent, we are going to get the solid compound in a solvent. That's why we are calling that as a solution. We are calling that as solution, means solution containing the solute and solvent. Means the solid, when it is going to form as a solvent, then it should undergo the dissolution. I hope this is clear for you. So solid, when we mix with the solvent, it's going to form as a solution. Solution is nothing but it should contain solute and solvent. when the solid dissolve in a solvent, that process is called as dissolution. On the dissolution, it is going to form the solvent. So it means to the water we are adding the sum of the salt. That the salt is going to mix with the water. Therefore, it is going to form the salt solution. Think that if the salts are we are removing, means they are going to mix, they are going to dissolve. That process is called as dissolution. So some extent we are dissolving that, means we go on adding the salt and it is mixing. So here I was telling you, when we are adding the salts, so when we begin to add the salt, initially as we are adding the salt is going to dissolve in a water. The process of salt is going to dissolve in the water, that is called as dissolution. For some time, to some extent, the salt is going to dissolve in the water. If we begin to add the continuously salt in the water, so initially it will dissolve and later the salt, excess of the salt will be settled in the bottom. So excess of the salt is settled in the bottom, it means that, so initially it is going to form as a dissolution, means it is mixing. After some, if the capacity of dissolving of that water is finished, then it do not undergo the dissolution. So it means constant. Then we are calling that as, it's not undergo the only dissolution, at the time it is also undergo the crystallization, means the dissolved compound, it is again coming outside to form the crystal, means salt is initially dissolving, the process is called as dissolution. After some extent, that the dissolved compound is again coming out of the water, that process is called as crystals, means it doesn't mean that it's not mixing. Initially it will mix, and the excess of the salt after mixing, the dissolved compound is again coming to the solid, means it's settling in the bottom. This phenomenon is called as crystallization. It is called as crystallization. Crystallization is nothing but formation of the crystal. Initially, the solid, when undergo the dissolution, is going to form as a solution. Means solid particles are present in the solvent. So further on some time, the solution, the solid which is present in the solution, it is again converting as a solid. That phenomenon is called as crystallization. How it is appearing, I hope you understand this one. So initially salt is going to dissolve in the water. After some time, if the excess of salt is added into the water do not undergo the tendency to dissolve the excess of the salt. So at that condition, the dissolved salt again coming as a solid, means it is coming in the form of crystal and settling down in the beaker, means in the water. So that phenomenon is called as crystals. So here one question will arises on the basis of this phenomenon, that is the process of or the stage at which both dissolution and crystallization taking place same time, means the rate at which dissolution and crystallization appears on the same time, means the phenomenon, the phase, the rate of formation of dissolution and crystallization occurs in an equilibrium. Equilibrium is nothing but the initially salt will dissolve, the dissolution is exceeded, means the completely the salt is dissolved, and later the dissolved salt is coming and it is settling in the bottom. That phenomenon is called as crystal, means again we continue to add the salt, means the added salt is dissolving, but already dissolved salt is coming out to form a crystal, means the phenomenon where the dissolution occurs and also the equilibrium is existing. The phenomenon is called as saturated. So what is saturated solution or saturated compounds? So here saturated is nothing but it is the phenomenon where dissolution and crystallization together happens in the same rate, same time. That phenomenon is called as dissolution. So it means that saturated solutions it is possible to create. What is saturated solution? Saturated solution is nothing but one time we are going to add the salt. That salt we are adding, but until that water have the capacity to dissolve that salt, that is called as saturated solution. So once we begin to add the salt, so we are adding, so and it is dissolving, and again we continue that adding. So after dissolving the water, the complete salt, some salt has to be settled down in the bottom. At that time, that the solution itself is called as saturated solution. Saturated solution. Keep in your mind, in the next chapter also, means in the electrochemistry, we are going to use this word saturated solution. It is possible to create. Take in your home, just take a glass of water, add excess of salt. Some salt will dissolve. The excess of salt will remains in the bottom. So such kind of solution itself called as saturated solution. Saturated solution. That phenomena is nothing but saturated solution or saturated compound. What is saturated means? It is a rate at which the dissolution and crystallization takes place in the same time, or together they are existing in the equilibrium. This is called as saturated solution. So this is important for 1 mark. And the next one is the most important. It is effect of temperature or solubility of solid. So here what we have to think, how we have to answer for this question is very important. My dear students, you may feel it is little bit difficult, no, never, not at all, because this chapter is totally based on your day-to-day life. Whichever I am explaining, you can do it as a theoretically or experimentally, because whichever I am telling, not only understanding, you just imagine that one so that it will be clear for your explanation. So what is next one is effect of temperature. Effect of temperature. Effect of temperature on solubility of, means solubility means we are going to dissolve the solubility of solid in liquid. Liquid. So it means we are taking the solute as a solid. In solid, it is in the form of solid, and solvent is liquid. This is the solvent and this is the solute. So here, what is the meaning is very simple thing. Think that we are adding the, whichever we are taking the solute, that solute should be in a solid and the solvent should be a liquid. So when we begin to dissolve a solid compound in a liquid, this process, dissolution is process, mixing of this compound, how it varies by changing the temperature. How it varies by changing the temperature. This is the simple question, and it is called as applied question. So if you understand the concept, it will be easy one. So I will explain you thoroughly to my idea. So if you still get confused, means feel free to ask, just call me, I will explain you. So it is very easiest method. So what is first one? The effect of temperature on solubility of solid in a liquid. So my question is here, think that you are dissolving the sugar. Sugar is a solid. You are dissolving sugar in a water. So water becomes sugar solution. Is it clear? You are adding the sugar to the water, so that water becomes sugar solution. So you just begin to add the sugar in the cold condition, means in the water. So water, it is a normal temperature. So initially if you dissolve, means it will dissolve. The same thing when you begin to dissolve the sugar, means after adding, you just heat the water. So when you are adding the sugar to the hot water, then the dissolution, means mixing of the compound increases, means it will dissolve very fastly. The solubility increases. How you can able to explain this one means? The question is the effect of temperature. As the temperature increases, whether dissolution, mixing of the solute in a solvent, whether it increases or decreases. This is the question. So how we have to explain this? It is not continuously increases. It's based on two conditions. So here, if you are adding the sugar in the normal temperature, it will dissolve, no doubt. If you are adding the sugar to the, as we increasing the temperature, means on heating that water, means temperature is increases. At that time the water becomes hot water. Hot water means in the hot water we can add the sugar and it will dissolve very fastly, isn't it? So it means that here sugar which on adding to the water, it increases means dissolution increases with increasing the temperature. How means the number one we have to preference that if the dissolution is a endothermic, the dissolution means mixing of the solute in a solvent. If it is a endothermic is nothing but on mixing the solute in a solvent, they should absorb the heat, they should not release the heat. If it is absorb the heat means then it is called as endothermic. If it is release the heat means then we are calling that as exothermic. So here to the water we are adding the sugar. So it is not releasing the heat, means it is not becoming cold, it can become the hot, means it is not actually becoming hot. So when we added the sugar to the water, if that solution is endothermic means it has to receive the heat. So if it is endothermic, as the endothermic it receives the heat. So when we increases the temperature, that dissolution also increases. Means the first one condition is as the temperature increases, the solubility means dissolution of solid in a liquid increases if the dissolution is a endothermic. If the phenomenon is purely endothermic, means it can able to receive the heat, then as the temperature increases, the dissolution also increases. Second thing is, if the dissolution process is a exothermic means it should not receive the heat, it should liberate the heat, means when we added some of the compound, it should release the heat and the solution should become cold. It is possible when you are adding a salt, means base compound, sodium hydroxide, if you dissolve in the water, that solution is going to become a cold. So it means it's not endothermic, it's an exothermic reaction, means it is releasing the heat. So in that condition, if you are adding the base to the water, means think that sodium hydroxide, it's a pellets you are getting white color. If you dissolve in the water, so it is an exothermic process means in the cold condition only it will dissolve. If you begin to heat that one, means as you increases the temperature, the dissolution of sodium hydroxide decreases. Why? Because it is an exothermic process. So same condition, as the temperature increases, the solubility of solid in a liquid decreases when the reaction, means when that dissolution is an exothermic. Only two things you have to remember. If the dissolution process is an endothermic, then as the temperature increases, dissolution increases. The second one is, if the dissolution is an exothermic, as the temperature increases, the rate of dissolution decreases. Are you getting this point? This is very simple concept. I hope you can able to understand this one. If you feel little bit fast, I think it's not fast. If you feel like that, just watch it once again. And if still confusion means, I will be here. You can call me and clear your doubts. This is important. It will be asked on applied question. Discuss the effect of temperature in solubility of solid. Keep in your mind. I am telling about the solid in a liquid. Solubility of solid in a liquid. This is important. And the second one is effect of pressure. What is the effect of pressure in same thing? Effect of pressure in solubility of solid in liquid. Same thing. To the solid, we are dissolving that in a liquid. So what is the effect? Means here we have discussed about the temperature. Next one is pressure. No need of even writing this one, because here effect of pressure, how the by increasing the pressure, whether the solubility of solid in a liquid increases or decreases. It will be question. The very one question is, it not undergo any changes, because it do not undergo any alteration by the pressure. Why? Because think that it is a solid compound. If when I apply the pressure to this one, if I press this one, means it do not undergo any changes, because only gaseous compound undergo the changes. Means to the any of the balloon, if I apply to the pressure, the gaseous compound is coming one near, and the gaseous compound is converting that as a liquid state. So it will be happens in the gaseous compound. When we are discussing about the solid, think that this is a solid. If I apply some pressure to this, the particles do not undergo any changes, because on the solid it is not possible to apply the pressure. So the pressure do not undergo any effect on the solubility of solid in liquid. ಸಾಲಿಡ್ ಒಳಗಡೆ ನಾವೇನಾದರೂ ಪ್ರೆಷರನ್ನು ಹಾಕಿದ್ರು ಸತಿ ಅದೇನೂ ಚೇಂಜಸ್ ಆಗೋದಿಲ್ಲ. ಯಾಕಂದರೆ ಸಾಲಿಡಿಗೆ ನಾವೇನಾದರೂ ಇದು ಸಾಲಿಡ್ ನಾವೇನಾದರೂ ಪ್ರೆಷರನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ ಅಂತಂದರೆ ಇಟ್ ಡು ನಾಟ್ ಅಂಡರ್ಗೋ ಎನಿ ಫಿಸಿಕಲ್ ಚೇಂಜಸ್. ಇಟ್ಸ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಎನಿವೇರ್ ಬಿಕಾಸ್ in the solid compound the particles are very tightly arranged so that they do not undergo any breakage or movement. Therefore there is no effect of pressure in the solubility of solid in liquid. You should remember it will be asked for 1 mark. So I hope this is clear for you. So this is regarding the solid compound, solubility of solid in a liquid. The next one is solubility of gaseous compound in liquid. So this is also very important. So on tomorrow we will discuss about this. So if you are having any doubts, clear it today only so that it will be easiest to understand. Okay. So we will meet on tomorrow. Until have a nice day. Bye.